Okay, so welcome to this next video in which we are discussing light microscopy. Okay, so we've been studying how a simple compound light microscope works. So basically we have our specimen here on this plane, and of course this is a plane. Even though I've drawn it as a line, it's a plane. So there'll be absolutely loads of points on this plane that we want to be able to see. Okay, and all of these points will have light coming from them. So we've drawn point A and point B to show as examples, and here is all of the light coming from point A, and what the objective lens will do is it will focus the light coming from point A all down to a point which we'll call the image of A here. It will also do the same for all of the light coming from point B. It will focus it down onto a point somewhere over here, and this point will be in the same plane basically here. And if you wanted to work out how far this plane is from the center of the microscope, all you'd need, from the center of the lens here, what you'd do is you'd use that equation 1 over u plus 1 over v is equal to 1 over f, where you'd need to plug in the focal length for this specific objective lens here, and you'd also need to know the distance of the specimen plane here from the objective lens. Okay, and of course it's going to magnify the image because it's going to space out all of the points basically. Okay, and it's also going to invert the image, so the image will appear upside down and also back to front. So what's now going to happen is that this image will go through the eyepiece lens. So you alter the distance of the eyepiece lens from the from the objective lens over here, so that the plane where the objective lens is focusing the image onto is a distance equal to the focal length for the eyepiece lens away from the eyepiece lens. Okay, and what that means is that all of the points of this image that are giving off light. Okay, so light is coming from all of these points. They're not obviously producing it, but it's coming from there at least. All of this light will go through this eyepiece lens, and it will be focused so that all the light coming from a single point will be going parallel. Now, of course, again, we have a plane of points here. Okay, so each point will have its light beams focused so that they are going in a certain direction. So each point will have a unique direction basically. So for instance, point B here has got this direction in which all of its light beams will be focused, and even though I've just drawn two, in fact there'll be loads of the things. Okay, and they'll all be going in a certain direction, and although I'm only drawing a 2D picture, of course it'll be a 3D direction. Okay, and again, for every single point on that plane you'll have a unique direction. Now this is just what the human eye is designed to do basically. It's designed to focus light that is coming in horizontally like that, and it will focus all light that is coming in a certain direction onto a certain point, a specific point for that direction on the retina. So now what will happen is all of the light from a point on this imaginary plane here will be focused onto a certain point on the back of the retina basically. Okay, now what you have to understand is that this is still going to mean that the image is inverted, because the image that the retina is getting is still an inverted image basically. Now of course when it finally actually does get onto the retina, it will actually be the right way round. So it will be the right way round, but the brain is designed to flip the image the other way down, because usually when we're looking at the world around us, the image on the retina is upside down, so the brain flips it around. So this time the image on the retina will actually be the right way round, but for all the wrong reasons basically. So the brain will then flip it upside down. So the image that you do get for a compound light microscope is upside down. Okay, and it's because basically this eyepiece lens is not going to flip the image back another way. It's because we've modified it so that the distance between this plane and the eyepiece lens is the focal length, so it's going to send them off all parallelly. It's not going to re-invert the image basically. Okay, so the image that you see down a compound light microscope is inverted. Okay, so that concludes our discussion of light microscopy.